Right. We are done with the triangles. Now we are on circle geometry. We are on circle geometry. Let's say this is our diagram 1 and this one is our diagram 2. In diagram 1, in diagram 1, we are having a tangent line. Let's make it a line segment TAN. TAN is what is a tangent, meaning it is a line that touches the circle at one point. Then we are having what? We are having a diameter. A diameter is a line that is drawn from, before we go to the diameter, let's go to a chord. A chord, we're having a chord. A chord is a line that is drawn from one point on the circumference of the circle to another point on the circumference of the circle. Here is our chord. A line drawn from the circumference of the circle to the circumference of the circle. Now a diameter is also a what? A chord. Drawn from the circumference of the circle to the circumference of the circle, but it is passing through the what? The center of the circle. Therefore, if the chord passes through the center of the circle, then that chord becomes a what? Becomes a diameter. Meaning a diameter is a special chord. And then we also have a what? A radius. A radius is a line that is drawn from the center of the circle to the circumference of the circle. Now, we've been talking about the circumference of the circle. What is the circumference of the circle? The circumference of the circle is what? Is simply but it is just simply the perimeter of the circle, the distance around the circle. Circumference, we are talking about the what? The perimeter of the circle. You see in diagram number 2, we are having what? Another chord. We are having another chord here. Let's call it what? Chord AB. Chord AB. Now in a circle, a chord divides a what? A circle into what? 2 segments. The major segment number 2, the bigger one, and the minor segment number 1, the smaller one. Then we also have what we call the what? The arc. We also have what we call the arc. An arc is a what? An arc is a smooth curve that is joining what? That is joining 2 end points. So let's take the end point A and the end point what? B. Therefore, this curve, this red curve that is joining the endpoints of A and B, we call it a what? An arc. That is an arc. A smooth curve joining the endpoints. Circumference segment. We have touched on the what? On the arc. Now, from the circle geometry, we will be talking a lot about what? Subtend. This subtends this subtends that, this subtend. This is what we mean by what? By subtending. Let me have let's have a circle, and then from there, let's say this is point A, and we say this is point B, and then let O is the what? Is the center of the circle. What do we mean by subtend? Now, if I'm going to draw a straight line from point A and another straight line from point B, where those straight lines cross or meet, then they make an angle. That angle will be subtended by what? By arc AB. That is what we mean by what? By subtend. Meaning we're having a straight line AO, another straight line OB. Then we are saying what? Angle O1 is subtended by what? By arc AB. Then if maybe we have another straight line from A to the circumference of a circle and another straight line from B to the circumference of the circle, and then where they meet there at the circumference of a circle, it is at what? At point C. Again, we are saying what? Arc AB subtends what? Subtends angle C. That is what we mean by what? By subtending. And then if maybe we are to join point A and B with a straight line, let us use a different color. With a straight line, then line segment AB will be a what? Will be a chord. So you see now both angle A1 and angle C, they are what? They are subtended by chord AB. Also arc AB. Chord AB, chord is a straight is a line segment, and then an arc is a what? Is a curve joining what? Two endpoints. So from point A to point B, we are having what? An arc and what? And a chord. So the chord subtends angle A1, also subtends angle C, and an arc subtends angle A1 and also subtends angle C. That is what we mean by what? By subtending. Right. Then let us now have a look at what? The first tool from the theorem statements under the circle geometry. In A, we are dealing with the tools whereby we are given what? We are given the center of the circle. So in A, Roman figure 1 up to Roman figure Roman figure 4. This should be 4. Roman figure 4. We are dealing with what? We are dealing with the diagrams whereby in all those diagrams, O is the what? Is the center of the circle. All right. Number 1, we are seeing what? A line drawn from the center of the circle perpendicular to the chord bisects the chord. Therefore, it means what? If OB is perpendicular to AC, then it means what? Line segment AB is equals to line BC. And then your reason for that is what? Line from center perpendicular to chord. Then number 2, if a line is drawn from the center of a circle to the midpoint of a chord, then that line is perpendicular to the chord. Meaning, if AB is equals to BC, then it means what? OB is perpendicular to AC. And then your reason for that is line from center to midpoint of chord. That's your reason for using that theorem statement. And then number 3, we are having angle at the center is twice angle at circumference. We have already defined what the circumference. So now the theorem statement angle at the center is twice angle at the circumference. Let us fully qualify it. We are saying angle O1. Remember, we know that O is the center of the circle. Angle O1 O is the center. Angle O1 is an angle at the center. And then angle A here, it is an angle at the what? At the circumference of the circle. The only reason why angle O1 will be twice angle A, it is because both angles, angle A or angle O1 and angle A, they are subtended by the same arc. If the two angles are not subtended by the same arc, then we cannot say that angle at the center is twice angle at the circumference. Angle at the center will be twice angle at the circumference if both angles, the one at the center and the one at the circumference of the circle, they are subtended by the same arc. So even in the second diagram, under number 3, we are still having what? Angle at the center twice angle at the circumference. But now, which angle? Angle O2. You see? Angle O2 will now be twice angle what? Angle B. Why? Because O2 is subtended by major arc AC. And major arc AC also subtends angle B. Therefore, angle O2 will be twice angle B. Reason, angle at the center is 2 times angle at circumference. And then also in diagram number 3, angle at the center is twice angle at the circumference. Angle O1 will be twice angle what? Angle A. Both angles are subtended by arc BC. And the last diagram, under number 3, we are also still having what? Angle at the center is twice angle at the circumference. Angle at the center being angle O1. Angle at the circumference being angle C. We are saying what? Angle O1 is twice angle C. Why? Because both angles, they are subtended by the same arc. You see arc AB subtends O1 at the center of the circle. And arc AB subtends angle C at the circumference of the circle. Angle at the center is twice angle at the circumference. And then in number 4, AC is a what? Is a diameter. AC is a diameter. Why? Because it is passing through the center of a circle. Therefore, a diameter subtends an angle of what? Of 90 degrees. Therefore, this means what? Angle B will be equals to 90 degrees. Your angle, your reason for that will be what? These are angles in semicircle. Angles in semicircle. Right. And then now in B, we are now going to have a look at the tools that have to do with what? With tangents. Number 1, we are saying what? A radius is perpendicular to a tangent at the point of contact. Meaning we know that TAN is a tangent and OA is a radius. Radius is a line that is drawn from the center of a circle to the circumference of a circle. And the point of contact is point A. Therefore, we are saying what? Angle OAN will be equals to what? 90 degrees. What is the reason? The reason is what? A tangent is perpendicular to radius. Now, let's say you are having a what? Not a radius, but rather a what? A diameter. Let's say you are having a diameter AC. Still, angle CON, angle C, not CON, but CAN will be equals to 90 degrees. And your reason will be what? Tangent is perpendicular to diameter. Meaning a diameter will be perpendicular to a tangent at the point of contact. And then number 2, under the tangents, we are having what? The Tancourt theorem. Tancourt theorem says an angle between a tangent. What is our tangent? Our tangent is TAN. An angle between a tangent and a chord. Which angle is that one? It can be angle A1, it can be angle OA what? A2. So let's say we are talking about what? Chord AC. Ne? We are talking about chord AC. An angle between a tangent and a chord, of which is what? Chord AC. Therefore, that angle is what? Is angle A1. Then we are saying what? That angle will be equals to an angle in an alternate segment. Therefore, remember we said what? A chord divides the circle into 2 segments. Therefore, which segment we are talking about? Chord AC divides the circle into two segments, segment 1 and segment 2. And angle A1, it is in what? It is part of an angle in what? In segment A1. Therefore, the other segment will be what? Will be segment number 2. Now, again, to further qualify the Tancourt theorem, of which it is fully qualified from your what? In the theorem statements in the examination guidelines. Then we say an angle between a tangent and a chord, tangent TAN and chord AC, will be equals to an angle in an alternate segment, and that angle must be subtended by the what? By the chord we are talking about. Segment 2, alternate segment is segment number 2. So any angle in segment number 2, but that angle must be subtended by what? By this chord that we are talking about, chord what? Chord AC. And then that angle is what? Is angle B. Angle B is subtended by chord AC. Therefore, Tancourt theorem, angle between a tangent and a chord is equals to an angle in an alternate segment. So it means what? Even if now we are taking what? Chord AB, we are saying what? An angle between a tangent and a chord will be what? Angle A2. That angle will be equals to an angle in an alternate segment. But that angle must be subtended by the what? By chord AB. Which angle is that one? Is angle C. Therefore, we are saying now what? Angle A2 is equals to angle C. And for both statements, the reason will be what? Tancourt theorem. And then the converse, let's say we are just having a what? A circle and a line. We are having a circle and a line. This line, let's say, is line what? ABC. We are not told that ABC is a what? Is a tangent. We do not know that ABC is a tangent. And then this is what we have. Then let's say this is PQ. And then we can say this is angle B1, angle B2, angle B3. That's the picture that we're having. But now, from the calculations, you have proved that angle B3 is equals to angle P. Therefore, you've proved that an angle between a line, which line? Line ABC, and the chord, which chord? Chord BQ, is equals to an angle in the what? In the alternate segment. Therefore, what does it mean? It means, therefore, you can conclude to say it means ABC is a tangent. It means ABC is a tangent. Therefore, your reason for that will be what? Will be converse. You just say converse Tancourt theorem. So even in a diagram whereby you are just having something like this, and then we are having a line, then we are saying what? This is D, E, F, and then this is, let's say, AB, and then this is angle A1, angle A2, and angle A3. And when you do the calculations, you are able to prove that angle E1 is equals to angle what? Angle B. Therefore, it means what? Therefore, it means DEF is a tangent. The reason? Same reason. Converse Tancourt theorem. Meaning what? We can just what? Construct a what? A circle that is passing through the vertices A, B, and E. So that is your what? Your converse of Tancourt theorem. All right, and then number 3, still under the tangents, we are saying two tangents that are drawn from the same point outside the circle are equal in length. The point outside the circle is point BC. What are the tangents? CDE and CBA. They will be equal in length, but they will not be equal from what? From E to C or A to what? To B. They will be equal from where? From the point of contact D, the point of contact B, meaning we are talking about what? DC will be equals to what? BC. Then the reason for that will be what? Tangents from same point. Times from same point. We are done with the tangents, and then now we are moving to what? To cyclic quadrilaterals. Number one, we are having what? A cyclic quadrilateral ABCD. Why is it a cyclic quadrilateral? Because the quadrilateral ABCD, the vertices of the quadrilateral ABCD, all the four vertices A, B, C, and D, they are on the circumference of the circle. Therefore, it is what? A cyclic quadrilateral. Then, what do we know about cyclic quadrilaterals? Opposite angles of cyclic quadrilaterals are supplementary, meaning opposite angles add up to 180 degrees. Meaning angle A plus angle C will be equals to 180 degrees. And then angle B plus angle D will be equals to 180 degrees. And then the reason for the two statements will be what? Opposite angles of cyclic quad. Then what do we know again about what? Now just what? Quadrilaterals. Angle A plus angle B plus angle C plus angle D will be 360 degrees. And then your reason for that will be what? Sum of angles in quadrilateral add up to 360 degrees. Not just what? Cyclic quadrilateral, any quadrilateral. All right. And then the converse. The converse of our cyclic quadrilateral. Let's say we are having a quadrilateral PQRS. Quadrilateral PQRS. And from quadrilateral PQRS, we can prove that angle P plus angle R is equals to 180 degrees. Therefore, we can conclude to say what? PQRS is a cyclic quadrilateral. And the reason for that will be what? Converse. These are what? The opposite angles of a quadrilateral. Therefore, it will be converse opposite angles of cyclic quad. Meaning you just take the reason of opposite angles of cyclic quad, but you start first by saying what? Converse. Or you can use what? The other reason of which it is what? Opposite angles of quadrilateral are supplementary. Or you can just say converse opposite angles of cyclic quad. And then number two, again, we are having cyclic quadrilateral ABCD, where DC is produced to E or is extended to E, meaning DE is a straight line. Then we are saying what? The exterior angle of a cyclic quadrilateral is equals to the interior opposite angle, meaning the exterior angle will be angle what? Angle C1. And then which angle will be the interior opposite angle? It will be the angle that is opposite what? The angle that is adjacent to the exterior angle is what? Is angle DCB. Therefore, an angle that is opposite DCB, that is the what? That is the interior opposite angle. Then we can say angle C1 will be equals to angle A. Reason? Exterior angle of cyclic quad. And then the converse, let's say we are having quadrilateral. Let's say we are having quadrilateral D, E, F, G, and then FE is produced to S. And then we're having angle SE1, we're having angle what? E2. FE is produced or extended to S, meaning FES is a straight line. Then in this quadrilateral, if we can prove that angle E1 is equals to angle G, angle E1 is equals to angle G, meaning the exterior angle of a quadrilateral is equals to the interior opposite angle of a quadrilateral. Therefore, this makes what? This makes DEFG to be a what? A cyclic quadrilateral. DEFG is a cyclic quadrilateral. And then the reason will be what? Converse exterior angle of cyclic quad. Or you can give the reason what? Or you can just say exterior angle of quadrilateral equals to interior opposite angle. Although I would recommend that you take what? The first reason, converse exterior angle of cyclic quad. And then number three, on our diagram, the vertices A, B, D, and C, they are on the what? On the circumference of the circle. Therefore, if this is the case, this means what? This means angle A will be equals to angle B. And also it means what? Angle C will be equals to angle D. And then the reason for that will be what? These are angles in the what? In the same segment. These are angles in the same segment, or angles that are subtended by the what? By the same arc. You see, let's look at angle D. You see, we are having what? Arc AB. You see, arc AB subtends angle D. I've shown you how to subtend. What do we mean by subtending? And then also arc AB subtends which angle? Angle C. So therefore, these are what? These are angles that are subtended by the same arc, or angles in the same segment. In the same segment, why? It's because if you are to join A and B with a chord, we will now be having what? Different segments. And also if you are to join what? C and D with a straight line, making CD a what? A chord, then we'll be having what? Two now what? Segments that are divided by what? By chord CD. Okay. And then now D, these are theorem statements or tools that are just talking about what? Chords. Now you see in the first diagram, let's say this is diagram number 1, this is diagram number 2. In the first diagram, we have triangle ABC, and we also have triangle DEF. Then side chord BC in triangle ABC is equals to chord EF in triangle DEF, and the two triangles are in the same circle. Therefore, this means angle A will be equals to angle D. Why? Because the two angles are subtended by what? By equal chords. Then we are saying what? The reason will be what? Equal chords, equal angles. Meaning equal chords will subtend equal angles. And then diagram number 2, we are having triangle OAB. Let's say OAB, and also triangle OPQ. In the two triangles, you'll see that chord AB in triangle OAB is equals to chord PQ in triangle OPQ. Therefore, angle O1, remember O is the center. Again here, O is the center. O is the center, then we are saying angle O1 will be equals to angle O2. Reason, equal chords, equal angles. Meaning what? Equal chords subtend equal angles at the center of the circle. The first diagram, equal chords subtends equal angles at the circumference of the circle. The second diagram, equal chords subtend equal angles at the center of the circle. But the reason is the same. Equal chords, equal angles.